Okay, here's my video guide for lesson 924. 924 is the last lesson in chapter 9. It's the last lesson that we do constructions for, and we end with the constructions of medians and centroids of a triangle. I've modified this lesson quite a bit because some of the questions I didn't really like. So the lesson that you get is the modified lesson, and so what I'm going to be doing, because my Smart Notebook file is a little bit different, is I'm going to be bouncing around from the Smart Notebook file to the lesson file and to the ebook and Desmos activities. So there's four things going to be bouncing around here. The ebook is nice for the first question, so that's probably the only time I'll use that. The lesson file is really going to be for the first two questions, and then the last question, 101, will be back on Smart Notebook. And of course, I'm using that Desmos tool because that's really what I've been doing all my constructions on. Remember that I like to see copy and pasted screenshots of that constructions that you do. And also remember to try these out because constructions can be kind of a fun thing. And use this video if you get stuck. Especially for one like you'll see in the first problem 9-99. I really do want you to try that one. All right, well then let's get going. All right, and the first question is one that I modified, so it is part of the Google Doc or the lesson that you receive. And the first question just asks to write the definition of the following vocab words, and then we're going to construct what we're defining in part 2 of it. All right, and so the first one, the two words are centroid and medians, and you can find that definition, those definitions, by just going to your ebook. All right, so if you go on your ebook and you go to the lesson, the first question, 9-99, I changed, but has these two vocab words in here. All right, so you can click on centroid and it'll give you a vocab or a definition. You could click on median, it'll give you a definition. But my own two definitions are as follows. So I start with median, and a median is really a line that goes from a vertex down to a midpoint, or down to, I should say, the midpoint of the line across from it. Okay, so a line that goes from the vertex down to the midpoint of the line across from it. What that means, if I click on it, the picture does a nice justice. So A would be my vertex, and then AD is my median. It goes from a vertex down to the midpoint of this line CB. And I know that's the midpoint of CB because this part is equal to the part over here. It's getting bisected. Okay? Now, a centroid, my definition of a centroid is the intersection point of the medians. So when you have all these medians, you have all these lines that are going from vertexes to the midpoint across from it. All these medians will intersect at a point that's called the centroid. Okay, so medians, three medians usually because three vertexes, they intersect at a point called the centroid. Again, you could use these definitions right from the book, or you can try to come up with your own. I like to try to come up with my own. It helps me remember them. Okay, back to the lesson. So we have our two definitions. We need to now construct a triangle that has medians and a centroid. And so what I'm going to do is I'm going to open up my, that one's old. I'm going to open up my new one. And I'm going to construct any kind of triangle because this should work with any kind of triangle. So I have a triangle here. And I need to construct medians, and then those medians should give me a centroid. All right. Well, to construct a median, I need to go from a vertex down to a midpoint. All right. And to find out where the midpoint is on this line, there's two different ways. You could use the more tools, and you could use midpoint and click on a segment and it'll give it to you. That's not terrible, but I'm going to do it a different way. Okay. I'm going to do what we did for perpendicular bisectors. I'm going to do a circle from this line over to here and this line over to here. Okay. And I'm going to just move things up a little bit so you can see the point of intersection. I think my triangle might just be too big, which stinks. Wait, maybe I can get rid of this. Yeah, so I can go from here down to here, and what I just did was created a perpendicular bisector of this line. Well, I know that when that line gets bisected, this point right here is really the midpoint. That is the midpoint because a bisector is going to cut this perfectly in half. All right, and now I'm going to just do that for every side of this triangle. Is just create these midpoints. All right, so now I'm going to do it over here. I know that from intersection to intersection gives me a perpendicular bisector. That point right there is a midpoint. I hide the things I don't want. And I'll do it. I want to get rid of this point too. I'll do it one more time for this over here. I'm going to move my stuff so you can see it. And I have all my midpoints now. I'm just going to get rid of my circles and my perpendicular bisector there. And what I have now is I can go from my vertexes now. So I can go from this vertex down to my midpoint, from my vertex across from it to the midpoint, and from my vertex to the midpoint across from it. And right here, that middle point, I have just created a centroid. All these lines are medians. All of the 3 lines are medians. And this point right here, I'll even call it with a nice label, a centroid. Okay. Now, I think it also tells me on this problem I want to copy and paste it from Desmos, and so I'm going to do that. I'll take a screenshot of the centroid that I created with the medians, and I will put it into my lesson. When it's too big, shrink it down. All right. And then that's that whole question. We did centroid, we did medians, and then we created it on the Desmos e-tool. Okay, on to the second question here. We need to visualize a point inside triangle. This is going to be a little bit different. So this one we did the centroid and the median. Here we're going to see something else, all right? And I think this one's more preparation for something like we might study here in chapter 10 because this is the end of chapter 9. But let's just kind of see this investigation and what we're doing here. All right, so we're going to visualize a point inside of triangle ABC that is the same distance from each vertex. Now, that's not the case of a centroid. Each vertex that might be a different distance from each vertex. But we're going to visualize what that might mean here. So like some point in here that's the same distance from B as it is to C as it is to A. All right. In the first step here, we want to use the Desmos e-tool to create a triangle similar to ABC and then create a line that is a perpendicular bisector of AB. And so I'm going to go on to the Desmos e-tool. I'm going to get rid of what I've done. And I'm going to create a triangle that is similar to ABC. Doesn't have to be perfect, just has to be similar to it. Any triangle will work. And so I'm going to label it correctly this time too. This is going to be A, this will be B, and this will be C. And then the first part wanted me to create a perpendicular bisector of AB, and we already kind of did this in problem 1. I'm going to use the 2 circles and use their point of intersection to create a perpendicular bisector. I'm going to drag this up just a little bit. And I have a perpendicular bisector of AB. Again, we already saw this, but now we're going to keep that perpendicular bisector in here, and we're going to get rid of the 2 circles. So we have this perpendicular bisector here. All right, back to the lesson. On that same, I want to copy and paste a picture of it before I move on here. So I'll just take a picture right here, and we'll put it into the file. Right. In part 2, it says on this same triangle that we are creating, now do perpendicular bisectors for AC and BC. And so I'm going to go back to my Desmos. I already did AB. Now I need to do AC and BC. So I go A to C and C to A, and I'll create a perpendicular bisector here. All right. And then lastly, I will do C and B. Circle here, circle here. I'm going to have to drag it down just a little bit so I can see where I can intersect them from up here down to here. And I have all of my perpendicular bisectors. Now, this seems kind of odd because in the beginning of the question we were talking about, well, we wanted a point that was equal distance away from, we wanted to find a point that was equal distance from all the vertexes. And then we just started doing perpendicular bisectors, and now they're intersecting at this point. And so we'll go back to the lesson quick, and what are we doing here? Quickly, I'll screenshot a picture. Of where we're at in this process. And then the last part here, it says we want to create a circle that is centered at the point of intersection and extend it so that it intersects one of the vertices. What do you notice about the circle and the other vertices? And so what that's saying is we want to go from this point of intersection and take a circle centered at that point of intersection and extend it to one of the vertices. So I click here and I extend my circle out to one of my vertices. And what I get to see here, and what it's saying here is, what do you notice about the what do you notice about the circle and the other vertices? Well, if you start a circle and center it at that point and extend it to a vertice, that circle intersects all the other vertices as well, which means that all these vertices must be an equal distance away from that center point. Or another way to say it is that this circle has the same radius, or these are the same distance away because the radius is the same from the center to C, from the center to A, and from the center to B. So that point must be equidistance away. That's not a centroid. That's not a centroid. That's a different kind of point that is equidistance away from all the vertexes, and I can tell because of the circle intersecting all three of them. All right. So lastly, I'll take a picture of that and put it into the file, and then I'll move on to the last problem. I like these ones because I think they're interesting. Like the first one, we got to see median and centroid. That's a different intersection point and means something different than this intersection point. And we'll learn more about this kind of intersection here and this kind of quality of a triangle later on. But I just think this one's so interesting to build. All right, and then 9-101, I'm going to move back to the Smart Notebook file, but I'm also going to do it on the second video. So the second video, that's going to be the last problem. It shouldn't take very long. It's just a proof of some things about a centroid and medians. All right, and I'll do that, like I said, in the second video on Smart Notebook.